Dear students, we have learnt theories of the simple harmonic motion, and let's now solve some numericals based on this topic. So, go through the question. So, I'll be giving the relevant equations to the numerical, and the simplification part you can do it at home. Now, it's given that a block whose mass is 1 kg. So, the mass of the block is given 1 kilogram. Is fastened to a spring. The spring has a spring constant K, which is given 50 Newton per meter. The block is pulled to a distance x is equal to 10 centimeter. So, they have given the block is pulled x is equal to 10 centimeter from its equilibrium position at x is equal to 0 on frictional surface from rest at t is equal to 0. So, initially the block was at rest, now it is a pull through a distance x is equal to 10 centimeter. First one, calculate the kinetic energy. So, we need to find the value of K, kinetic energy, the potential energy, which is U, and the total energy of the block. So, we have to find even the total energy, which is E of the block, when it is 5 centimeter away from the mean position. So, initially when the block is pulled to a distance of 10 centimeter, that 10 centimeter is nothing but the maximum displacement of the block from the mean position, which is nothing but the amplitude. So, therefore, this value of x is nothing but a amplitude of the oscillation, okay, which is in centimeter. So, we need to convert, divide by 100, you will get 0.1 meter. And then we have to find the kinetic energy, potential energy and the total energy when it is at a distance x, which is given as a 5 centimeter. Convert this 0.05 meter. So, this is the conversion. Now, from m and k we can always calculate omega, okay, root of k by m. Omega is root of k by m. So, k is here, m is here, substitute, you will get the value of omega, which is in radian per second. So, that is angular velocity, that is called angular velocity, omega. So, now we need to find the value of k in terms of x. So, expression for k is a half m and then square of the velocity, which is velocity is given by a omega, that is in terms of x, it is omega into root of a square minus x square, that is velocity. So, half mv square. So, therefore, when I square it, I will get omega square into a square minus x square. So, this is the formula for kinetic energy. For potential energy, it is a half m omega square and then x square. It is half m and then omega square into x square. Now, that is the formula for the potential energy. The kinetic energy is half m v square, v is this, okay, which is omega into root of a square minus x square, and when you square it, you will get this value. Now, when you add these two, you will get the total energy. So, total energy is E is equal to K plus U is the total energy. Half m, mass of the block is given, omega we get it from here, correct. Amplitude is already given, maximum amplitude. X, position is given. So, you will get kinetic energy. What is the unit in which energy is measured? It is in joule. So, this is also in joule, this is also in joule. So, it is basically a direct substitution problem, and in most of the problems, so we need to find this value, omega. Sometimes they will give frequency, sometimes they will give time period. So, you can find using 2 pi f or 2 pi by t. So, this is the problem, and simplify this, make use of the calculator and then see what is the answer that you are going to get for all these numericals, clear. So, that is question 1. So, let us go for the next problem. Question number 2, a 5 kg collar is attached to a spring. So collar is it's a metal in the shape of C. Okay, it's like this, this is in the shape of C. So mass is given, mass 5 kg is attached to a spring of spring constant given, which is K, 500 Newton per meter. It slides without the friction over a horizontal rod. The collar is displaced from its equilibrium position by 10 centimeter. So same thing, that amplitude is a 10 centimeter, which is 0.1 meter. Like earlier, we can find the value of omega, which is the root of K by m, okay, which is in radian per second. When you know m and k, we can find omega. So what are the options? Position, right, from its equilibrium position by 10 centimeter and release, calculate the period of oscillation. So the first option is period of oscillation. From omega, we can always find the period of oscillation. How? Omega is equal to 2 pi by t, and from this the t is equal to 2 pi by omega. So time period of oscillation will be always in second. So omega, we get it here, 2 pi value 3.142. Okay, this is option A, this is option B. Now the maximum speed is nothing but V max. So V max is given by A into omega. A is the amplitude, which is here, omega is here, so multiply, you will get maximum speed. Speed is in always meter per second. Option C, maximum acceleration of the collar. Maximum acceleration means we find the acceleration of the magnitude of the acceleration, because normally acceleration is negative, so we take the magnitude, which is given by A omega square, so which is in meter per second square. So this is the maximum acceleration of the block. So again, similar to the previous problem where we have to find omega, and from omega we can find time period, and if they ask from the time period you can find the frequency as well, and this is the maximum velocity and the maximum acceleration. So hope the numerical is clear. So first you have to be very thorough with all those equations. Definitely they are all important for all form of exam, whether it can be a board exam or it can be even competitive exams as well. Let's go for the next question, which is question number 3. A body suspended from a spring balance when displaced and released oscillates with a period of 0.6 second. So time period of oscillation is given 0.6 second. From this we can find omega, which is 2 pi by t. So that's in radian per second. See, for most of the numerical we need the value of omega, so that should be the first point to find, 0.6. Then what is the weight of the body? So this is omega. Weight of the body is always equal to m into g. What is the weight of the body? Then given spring constant is given and acceleration due to gravity 9.8 meter per second square. Okay. So first spring constant I will write k, which is 2450 meter per second. Spring constant is given. After that acceleration due to gravity g is given, which is 9.8 meter per second square. Now when we know omega, so omega is here, omega, we can find m, because omega is equal to root of k by m, correct? So we want to find m so that I can find the value of the weight. Okay, so square it here. So when you square, you will get omega square is equal to k by m, and from this you can find m is equal to k, m is equal to k by omega square. So now we will get the mass of the body, correct? So first from time period we have found omega, and we also know the formula for omega, which is root of k by m. Since I have to find m, so we got the value. Now once you get the value of m, how to find the weight? Weight W is equal to m into g. So the weight is always measured in Newton. So one and other formulas are related here. So this weight is the formula which is used in Newton's laws of motion. So from there we use this particular formula. Clear? So Again, the value of omega or the formula of the omega is important. You can see we have almost used in every problem that we have solved so far. Okay. All right. So, hope the substitution is clear. Let's go for the next one, question number 4. A body executes simple harmonic motion along the y-axis. Its displacement varies with the time according to the formula. Y is equal to 1.5 sine 100 by t, where y is in meter and t is in second. Calculate the amplitude. So, we need to find the amplitude A and period t and then frequency. So, these are the things to calculate. So, this equation is of the format y is equal to A sine omega t, because that is the equation which represents simple harmonic motion. Now, you compare what is A, amplitude. So, A is 1.5 meter. Compare omega, what is omega? Omega is 100 pi. And we know that pi is not, so omega is equal to 2 pi f is 100 pi. So, this pi will get cancelled. So, we will get f is equal to 100 by 2, which is 50 hertz. And once you get the frequency, you can find the time period, right. So, t is equal to 1 by f, which is 1 by 50. So, 1 by 5 is 0.2, 0.2 by 10 is 0.02 second. So, this is the data given, problem given, very easy, simple. You can say it's basically a 5 marks question, but an easy problem to simplify, easy problem to solve. Now, the reason why we need to learn all these things, because these are the basics which we may use even in the second year topics, that is one thing. And all these topics are definitely included for the competitive examination. So, that is why, so study them, learn them, because this kind of questions. So, now you can see we have solved it without using the calculator. Such kind of problems will definitely appear for the competitive examination. So, let us try one more numerical question number 5. A particle executes simple harmonic motion along the x-axis. The displacement varies with the time according to the equation x is equal to 5.4 cos 6 pi t plus pi by 4. Where x is in meter, t is in second. Determine the amplitude, the frequency, period and the initial phase of the motion. Okay. Now, this equation is of the form x is equal to a cos omega t plus phi. So, a is first amplitude, a is equal to 5.4 meter. Omega is 6 pi. So, from omega we can find 2 pi f, which is 6 pi. So, f is equal to pi will get cancelled here, pi. So, f is equal to 6 by 2, which is 3 hertz. So, time period is 1 by frequency, 1 by 3, which is 0.3333 second. And this is called the initial phase of the particle. So, what exactly the phase term, so that I will explain. But if you compare here, phi is how much? Pi by 4, pi by 4 radian, or you can even write 45 degrees. So, that is the initial phase. So, we have calculated all the option that is asked, whether it is amplitude or frequency or the period or even the initial phase. This is called the initial phase of the simple harmonic motion. Okay, right. So, all easy sums. Okay, so let us try again one more numerical. A spring compressed by 0.2 meter develops a restoring force. So, they have given a restoring force F is equal to 25 Newton. A body of mass 5 kg, mass is given 5 kg, is placed over it. Calculate the force constant. So, we need to calculate the value of the force constant. Then elongation of the spring under the weight. Now, here when force is given, a spring compressed by 0.2 meter. For this force, the compression is given 0.2 meter. Okay, for this, for the first option. When this force is applied, this is the compression, so that we can find the value of K. What is K? K is equal to F by X. So F is 25, X is a 0.2, that's 250 by 2, 125 Newton per meter. That is the first part of the problem. Okay. For this force, this is the displacement, so we can find the value of K. And now, for the second, it's given that a mass of 5 kg is placed. Okay. A body of mass 5 kg is placed over it. Calculate the force constant, that's over. And now for this mass, what is the elongation? We need to find the value of X, elongation of the spring under the weight of the body. Under the weight, what is the elongation? Now, to find the value of X, so we can equate like this. mg is equal to K into X. The weight itself displaces the spring. The weight, if for a spring, if you attach a load, it will get displaced, right? The length of the spring increases. So therefore here mg is equal to Kx, and we can find the value of X using mg by Q. M is 5 kg. G is given at the end, which is 10 meter per second square. The value of K we have found it here, so you can find the value of X. So that's the elongation, which is in meter. So that's the second option. And the third is a period of oscillation of the body. So time period is given by 2 pi root of m by k, which I have again given in the last class. T is equal to pi root of m by k. M is the mass here, 5 kg. K, we have found it. So we can find the time period in second. So hope you will have understood all the numericals that we solved related to this particular chapter. We have completed all the numericals part. They are all easy numericals. Okay, so solve them and then simplify, and then let me know what are the answers that you get for all the numericals. So I'll continue the rest of the topic of this particular chapter, and I will complete this chapter in the next class. Thank you.